Hello everyone, my name is Muhammad Asif and I am here with a new lecture whose name is Energy Transfer and General Energy Analysis Part 2. Mechanical energy is the form of energy that can be converted to mechanical work completely and directly by an ideal mechanical device such as an ideal turbine. Kinetic and potential energies are the familiar form of mechanical energy. Thermal energy is not mechanical energy. Why? The reason is a pump transfers mechanical energy to fluid by raising its pressure. A turbine extracts mechanical energy from the fluid by dropping its pressure. So pressure is associated with mechanical energy. The unit of pressure is Pascal or Newton per square meter or Newton meter per cubic meter or Joule per cubic meter. This is also called energy per unit volume. It can also be expressed in joule per kg. Pressure itself is not a form of energy, but pressure force acting on fluid through a distance produces work, which is called flow work, whose unit is joule per kg. Mechanical energy of flowing fluid can be expressed in a following way. Small e mechanical is equal to P by rho plus V square by 2 plus Gz. P by rho is called flow energy, V square by 2 is called kinetic energy, Gz is called potential energy. Delta E dot mech is equal to mass flow rate multiplied by pressure difference divided by density plus uh, velocity difference square divided by 2 plus g into height difference. Its unit is kilowatt. Basically delta E dot mech is change in energy rate. So mechanical energy of fluid does not change if its pressure, density, velocity and elevation remains constant. Pressure, density, velocity and elevation does not change, then mechanical energy does not change. In the absence of any losses, mechanical energy change represents the work supplied to fluid if delta E mech is greater than 0 or extracted from fluid if delta E mech is less than 0. Energy transfer by heat. Form of energy that is transferred between two systems or a system and a surrounding by virtue of temperature difference. If two systems are at same temperature, then heat transfer does not take place. Several phrases are common use in today. Heat flow, heat addition, heat rejection, heat absorption, heat removal, heat gain, heat loss, heat storage, heat generation, electrical heating, resistance heating, frictional heating, gas heating, heat of reaction, liberation of heat, specific heat, sensible heat, latent heat, waste heat, body heat, process heat, heat sink and heat source. If there is hot cup of tea and some ice in an other cup on the table, heat heat transfer would take place in both cups until the temperature of both cups are equal with surrounding. Adiabatic process, a process in which no heat transfer take place. The word adiabatic comes from Greek word adiabatos, which means not to be paused. Adiabatic process. There are two ways a process can be adiabatic. Number one, either the system is well insulated so that only a negligible amount of heat can pass through the boundary. Number two, or both the system and surrounding are at same temperature so there is no temperature difference for heat transfer. Rate of heat transfer. Amount of heat transfer per unit time, kilojoule per second. Heat transfer per unit mass is denoted by small q and is determined by small q is equal to capital Q divided by m. Its unit is joule per kg or kilojoule per kg. Energy transfer by work. Energy transfer associated with a force acting through a distance, a rising piston, rotating shaft, and an electric wire crossing the system boundary is associated with work interaction. Work done per unit mass has unit kilojoule per kg. Work done per unit time is called power. Its unit is kilojoule per second or kilowatt. Both heat and work are vector quantity. Work done by system and heat transfer to the system are positive. Work done on a system and heat transfer from a system are negative. Mechanical form of work. Force acting on a body displaced at a distance in direction of force is called work. Shaft work, spring work, work done on elastic solid bar, work associated with stretching liquid film or some forms of mechanical work. Only kinetic and potential energy change can cause a work. Energy conversion efficiency. Heating value of a fuel. Amount of heat released when a unit amount of fuel at room temperature is completely burned and the combustion products are cooled to room temperature. Combustion efficiency is equal to ratio between amount of heat released during reaction divided by heating value of fuel burned. Higher heating value. When the water in combustion gases is completely condensed and heat of vaporization is also recovered, then it is called higher heating value. Lower heating value. When fuel is burned, it contains water in liquid or vapor form. Heating value is called lower heating value. Thermal efficiency. Ratio of net shaft work output of turbine to heat input to working fluid. Generator efficiency. Ratio of electrical power output to mechanical power input. Overall efficiency. Net electrical power output to rate of fuel energy input. Lighting efficiency. Ratio of amount of light output in lumens per watt of electricity consumed. Efficiencies of mechanical and electrical devices. Number 1 is pump. The transfer of mechanical energy is usually accomplished by a rotating shaft, and thus mechanical work is often referred to as shaft work. A pump or fan receives shaft work and transfer it to fluid as mechanical energy. Pump efficiency. Mechanical energy increase of fluid divided by mechanical energy input. Turbine. A turbine converts mechanical energy of fluid to shaft work. Turbine efficiency is ratio between mechanical energy output and mechanical energy decrease of fluid. Electrical energy is converted to mechanical energy by electric motors to drive fans, compressor, robot arms and car starter. Motor efficiency is ratio between mechanical power output to electrical power input. Generator. A generator is a device which converts mechanical energy to electrical energy, and efficiency of generator has a formula which is ratio between electrical power output to mechanical power input.